Hello. Today we will discuss on one major aspects of spatial informatics. So long if you see that we talked about different things, like one is that how data is stored, model, and also though we worked on spatial networks. So, different category of things. Next couple of lectures or few lectures we will be discussing on this, so to say, spatial analysis. Actually it will have lot of other things, means lot of not other things, lot of different dimension, like looking at spatial data mining, then working on this spatial autocorrelation, spatial computing. So, or also if feasible, if we look at a, so that spatial data analytics or the spatial data analytics aspects of the things, right. So, today specifically we look into one aspect of spatial data warehouse, or more of a spatial data warehouse and data mining. Before that I thought that it will be good for many of you who are not gone through for formal data warehousing or data mining courses, to have a background or the basics of data mining, data warehousing and data mining, few lectures on those things, right. So, so basically we plan to cover these aspects in next few lectures, and today more specifically we look at the data mining, data warehousing and data mining per se. So, if you look at today's data sets, so we have huge volumes of data, right. So, as most of our things are digitally enabled, so there are huge volume of data which are in place. The problem is now how to retrieve meaningful information from it, which I need, right. There may be lot of sensor data, but for my particular purpose, it may be research, it may be some metrological analysis, etc. I need a data which mean for that. So, can't find the data I need. Data is scattered over network, that several form of the data, many version, there are different sort of subtle differences, right. So, there is a serious problem. I can't get the data I need. So, first of all, where to find the data, then how to retrieve or get the data, need an expert to get the data, right. So, I need a expert to tell that this data is particular for this purpose and so on. I can't understand the data I found, right. Available data are poorly documented. So, you may get a huge volume of data, but the available data is poorly documented, can't use the data I found, right. Results are unexpected, like there need to be cleaned, they need to be find out that whether the data there is any error in the data, or there is something we need to have a appropriate scaling down of the data or appropriate scaling of the data. The data need to be transformed from one form to other to do that. So, this sort of problems we are facing, especially when we want to do a large scale data analysis, so to say. So, in order to handle this, so we may require some sort of a appropriate mechanism to store, manage this data, or what we say warehousing of the data. So, this is a generic statement or generic curve you might have seen in different aspects. So, what from the data we want to go to a information, right. It is true for spatial data, it is true for non-spatial data also, right. It is true for any data set. So, a process of transforming data to information and makes it available to the users in a timely manner to make a difference, right. So, appropriately if we can make it to information, etc. So, in other sense, before I process the data, so data need to be so to say uplifted to a form where it can be easily processable. So, that is one aspect of the this sort of warehousing aspects, right. So, there are so when if we say what is warehousing, there are different type of definitions. A decision support database that is maintained separately from organizational operation database, right. So, operational database means it is a transactional database which is going on, right. There are like say a banking operation. So, all these counters, all the activities going on, these are the operational data. But if I want to know that profitability of the bank or how the bank growth is going on and etc., that I need to work in the look at the some form which is not it definitely the input come from the operational data, but I need to analysis data in some other form, right. Like I want to do a traffic analysis of a particular road network, say Kolkata or Kharagpur or Pune or somewhere, right. In order to do that, one is the recording of the data of every instances, right. Either it can be the GPS from the vehicle, or it is recorded at the junction by this intelligent sensory system, like it may be cameras or other type of vehicle count, etc. And then, but those are what we say operational data. But in order to do that, what is the pattern of traffic movement on a particular time of a day, on a particular day of a week, I need to analyze those data in some form. So, I require, in order to run this analytical tools, I require a data which is not the operational data, it need to be what to say transformed to some other form of data. So, that is why we are telling that has to be maintained, which is more amicable for decision support. So, support information processing by providing a solid platform of consolidated historical data for analysis, right. So, a data warehouse is a subject oriented, integrated, time variant and non volatile connection of data in support of management decision making process. So, that is one of the very straight cut. So, it is something you see, we can see that something highlighted, right. Object oriented, subject oriented, this for a particular purpose, integrated, like I could able to integrate data from different source, time variant, it is there is a temporal scale also, and non volatile, it is not like that it will volatile and goes up. Usually our when we go for operational data transactions, that is that instant the data set is there, right. Others data set I overwrite on the things, it should be archived in a separate fashion, but the as such the traditional data processing thing, they are not responsible of maintaining those data per se, right. So, there should be a data management process to handle that, but warehouse is non volatile. So, the once it is in warehouse, it is non volatile data, right, and it is. So, if you see that if you look at the spatial data sources, so this request fits in, right, it should be particular thing, like if I work on the transportation, I look at the transportation part of it, right. So, if I the same or not exactly the same data, but a good amount of overlap data or the same data sets, if it is used for disasters management, I need to look at those point of view, right. Planning for a longer time, that to city planners, etc., that has to be looked into different aspects. So, what we do, we need to warehousing, like we do warehousing of other products, the process of constructing and using data warehouse as we are doing that warehousing of the data, right. So, what we say subject oriented, organized around major subject, for example, customer, product, sales, if we have a things, right, like if I go to a departmental store, or when if we consider things, it is a customer base, particular product, sales of a product and type of things, focusing on modeling and analysis of data for decision maker, not on daily operation on transaction and other things, right. It is more of a decision support type of things, right. Provide a simple and concise view around particular subject issues, particular subject by excluding data that are not useful in the decision support process for that particular thing. So, I may have all the data, but I can exclude those data, or I can take a aggregated form of the data, right. So, that exactly what we say when you look the subject oriented, it should be integrated, right. So, it is constructed by integrating multiple heterogeneous data sources, right. So, it can be different type of data sources coming into picture, like consider, like I want to look for a traffic movement on a particular segment of a city network, right. So, one of the data sources may be the time of the thing, that what I can have that previous data based scenarios. I need to look from other type of things, right, like it is I may to look for the weather condition, if it is a rainy something, if it is a normal day something, I need to look at that which time of the period, like if it is a mid of the night some way, it is the middle of the day, some other things, right. I also may look at to other aspects, like if it is a festival season, some aspects, if it is a weekday, weekend. So, that means there are different heterogeneous data sources which need to be integrated. So, there may be traditional relational database, fat file or online transactional databases which are which can be there, right. So, what we see that it is a integration of different data sources, data cleaning and data integration techniques are applied. So, I need to clean the data because as a huge volume of data there. So, there is a need to clean the data and data integration techniques, how to integrate the data, right. It may be I need a unified model. If you remember that beginning of these things, if you have a application schema or a integrated model that it needs to fit in, right. Ensure consistency in naming convention, encoding structure, attribute measure, etc. So, it need to ensure among different data sources. So, what in other sense quote unquote interoperability needs to be supported. If you remember the special web services and others, there where we talked about this those issues, right, where we things. When the data is moved to the warehouse, it is converted to a particular form which is amicable for decision support system for that particular organizations, right, or for that particular field. So, that is need to be that particular to be in the warehousing of the data. Next is data warehouse is time variant, right. So, time horizon of the data warehouse is significantly longer than that of the operational data. So, it is say operational data is a daily transaction or even may be within that particular duration of the thing, but the warehousing is much more, that is yearly or over 10 years, even monthly and different granularity. I can go back, scale down and scale up on the different scale, right. So, operational database is the current data value data. Data warehouse data provide information from a historical perspective, that is 10 years, 5 years type of long term data sets. Every key structure in data warehouse contains an element of time explicitly or implicitly. So, that is whether it is explicitly you define a time axis or implicitly it is the time axis is there. But the key of operational data may or may not have the, in case of operational data we may or may not have the key concept. Data warehouse are non-volatile, that is another aspects. So, a physical separate store or the data transformed from the operational environment. So, it is non-volatile. Operational update of the data does not occur in the data warehouse environment, does not require transactional processing, recovery and concurrency control mechanisms, requires only two operations, that is initial loading of data and the access of the data, right. So, it is what we require mostly, that loading, appropriate loading of the data in the particular form. So, that it is things are there, definitely data cleaning etc. will come into play, and how to access the data, right. Maybe on the temporal scale, say I want to access before 5 years, 3 years, 10 years data, if it is there, how that accessibility mechanism needs to be defined in the warehouse. So, if we, so this as we have seen, these are the basic core properties, so to say. It is non-volatile, time variant, integrated and subject oriented. So, these properties needs to be there, right. And obviously, the question comes that what is the gross difference between warehouse and heterogeneous database management system, right. So, traditional heterogeneous DB database integration build wrappers and mediators on the top of the thing. So, heterogeneous database is there, I make a mediating layer which takes care of this putting them into format and type of things, accessibility of the data and etc. And it is mostly query driven approach. When the query is posed to a client side, the meta dictionary is used to translate the query into the queries appropriate for the individual heterogeneous sites. So, the results are integrated into global answer sets. So, complex information filtering complete for resources. So, these are the things, right. Data warehouse, so it is update driven, high performance. So, it is update driven and high performance. Information from heterogeneous sources is integrated in advance, that means I basically do some sort of a pre-processing and stored in a warehouse for direct query analysis. So, it is as if I what we say pre-materialize the thing, right, keep it in a form which can be quote unquote half cooked, so that I can easily serve these decision support systems, right, which is the traditional our heterogeneous database system is not meant for that. So, another thing is that what is warehouse versus operational DBMS or queries type of things. So, it is like online transactional processing, it is the major task of the traditional relational data DBMS, right. Online transactional processing, day to day operation, purchasing, inventory, banking, manufacturing, payroll, registration, accounting, these are all operational OLTP type of operation is there. Whereas, what we look at this warehouse and other things is more of a OLAP, right, online analytical processing. Major tasks of the data warehouse system, data analysis and decision making is the major task. So, that type of what we say analytical, where that is more of a transactional processing, right. So, feature are OLTP versus OLAP, user and system oriented, customer versus market, data content, current details versus historical and consolidated, database design, ER plus application versus star plus subject, view, current local versus evolutionary and integrated, and access pattern, update versus read only but complex queries, right. So, these are typical things, right. So, one is user and system oriented, the customer versus market, data content is in case of our OLTP is more of a current and detail, and it is historical and consolidated, aggregation of the data is there. Database design, here we have ER diagram, application versus star plus subject, view, current local versus evolution integrated, and access pattern, it is update versus read only but more complex queries. So, usually data warehouse updates are not like transactional updates, right. So, data warehouse is something which need to be preserved for a much longer time, etc. So, the update etc. has to be very much regulated, and usually it is not done on the fly, right. It is from the from the transactional data set, other data sources, I do a pre-processing and put it on the warehouse, where mostly the read only queries will be there. So, why we require a warehouse? That is implied, say high performance for both systems, DBMS tuned for OLTP, access methods, indexing etc., warehouse tuned for OLAP, like online analytical processing, and complex OLAP queries, multidimensional views and consolidation, these are the major fact of warehousing. Different functions and different data, missing data, decision support requires historical data, which operational DBMS do not typically maintain, right. So, we require historical data, and if there is some missing data in the historical pattern, then it is like I require T's from the T0, T minus 1, T minus 2 etc. If that is T minus 2, T minus 3 instances are missing, so that has to be there. Data consolidated requires consolidation, aggregation and type of thing, that this will be DW. Data warehouse requires consolidation data from the heterogeneous sources. Data quality, different sources having typical use, inconsistent the data representation quality if I have a heterogeneous data sets. So, that need to be here appropriately consolidated into, so that the appropriate data quality is maintained, because all later on processing will be based on this, how quality data is there, right. So, different function, different data things are there. So, for this what we see that from our this I require a multi-dimensional data models, right, from the tables and spreadsheet to data cubes. So, that is the one thing what we require. So, a data warehouse is based on multi-dimensional data model which views data in form of a data cube. A data cube such as cells allows data to be modeled and viewed in multiple dimensions, right. So, we will see that how a data cube looks like. So, it is a cube of data, right. So, dimension tables such as item name, brand, type or time, day, week, month, quarter, year. So, these are different dimension tables, like time has different dimensions. So, you will require a daily sale, you may require weekly sale, you may require monthly sale, you may require quarterly sale or yearly sale, right. All are not aggregated in the things, right, when we do, like I may take the daily sales to make a monthly sales, but as such weekly sales may not fit into the monthly sales, like some month it may have different type of different days, like 30 days, 31 days, sometimes 28 days, 29 days and type of things. Even that way week to year matching will be again difficult, right. exactly it does not fits in. In other sense, if I have a concept hierarchy going up and down in the things will be there, but what we see that we can have different type of dimensions of the things, right. There is a concept called fact tables contain measure, right. So, if what I want to achieve, like one may be like dollar sold or total revenue earned, and key to each of the related dimension tables, right. So, that type of things. So, in a data warehouse literature, so there is ND base cube. So, in dimensional, right, 1D, 2D, 0D base cube. The top of the thing is the 0D. So, aggregated everything all. So, for all year, for all products, for all say item set, I want to find out the sales, right. So, that means one point. It can be having one dimensional, we say that for a particular time scale or a product scale or type of things. It can be two dimensional and so forth. So, which holds the highest value of summarization. So, I summarize that the total, the manager wants to know that what is the total sales of the things. I want to know that what is the total amount of traffic flown through this particular region. I am not looking for temporal and type of things. I may want to say that total number of traffic during this part of the time, or that number of, say now number of buses or number of four wheelers or two wheelers during this time on this region and type of things. So, those things are different granularity come into play, right. So, how do I do it? If I go from the transactional data, then I have to do a lot of multi-layer processing. Otherwise, I can keep a multi-dimensional data cube ready from where I can process these queries. So, what we say that lattice of the data cube forms a lattice of the qubit forms a data cube. So, you see this is the thing if we look at. So, here we have dimension time, item, location, supplier. So, for a particular time, for a particular item, for a particular location, for a particular supplier. So, this is the thing. Like at the other things that for all location, for all time, for all supplier and for all item, what is the things. My objective may be the finding the sales, how much revenue is there. So, there is a for all. Now, I want to say for a particular time, for all item, for all location, for all suppliers. So, what is the thing? Say month of March, if it is my monthly thing, or on particular day, say today's date or something, right, or on particular week, right. So, or I can say time and item for particular item and particular time for all location for all supplier. Like here the dimension is 3D cuboid, right, time, item, location, and then I have a 4D. So, all are there for a particular time period, for a particular item, for a particular location and supplier. So, these are 4D cuboid. So, I can have different relations. So, now, when if we can understand there is aggregation of the things are there, and I can query at different things. So, warehouse should have a mechanism to maintain these data sets, right. Now, if you little look back to your traditional relational databases or the type of things what we do with it, that this is not exactly fit in the things. Nevertheless, I require this transactional databases which is a relational database to make this warehouse ready, right. I require the data from here. I am not generating data. The warehouse is basically uploading the data in appropriate point where the queries can be there. Conceptual modeling of the data warehouse. So, how do I conceptually model? So, our traditional model may not work good here. So, one is the star schema, a fact table in the middle connected to a set of dimension tables, right. So, we will see slow fix schema. So, this is another thing, a refinement of the star schema where some dimensional hierarchy is normalized into a set of smaller dimensional tables and form a snowflake. So, star is that one all connected star, snowflake is there again expanding, right. Another is the fact constellation table, that multiple fact tables share the dimension tables viewed as a collection of the stars, therefore, called galaxy schema or fact constellation schema, right. So, there are different things and connected into the things. So, that can be another way of looking at the things. So, we have star schema, snowflake schema and the fact constellation schema. So, typically a star schema look like this. I can have different things like I have a time dimension, a branch key and the item key and a location key, right. So, for a particular time, for a particular branch where particular, think of a particular commercial chain, even our chain of say different shopping or different malls and type of things which are different place of the different places, different cities, etc. And then different items are there and different location is there. So, I have time, in the time we have the time key which is the primary key, day of the week, month, quarter, year, this is the time dimension, branch key, name, type is the branch dimension, right, item also and things. So, you can say that particular time, like for a weekly Excel, for a particular type of branch, for a particular item set on particular location, particular city or country or some province or state, I can find out these things. Now, if I could have stored, then my query which is more of a decision support, we need to remember these are primarily the query which is meant for the decision support system or supporting this higher management to do a planning and type of things, right. So, this is typically a star schema. So, if you look at a snowflake schema, you see it is the star schema, but some of the dimension are expanded, like here from the I have a item which has a supplier key which links to a supplier, or here is city key links to a particular things, right, city key, city, province, state, etc. So, it is a snowflake schema. So, one thing it is I just missed here also, there are some units, this is my goal, I want to find out units sold, dollar and average sales, this is my goal. There can be several goals based on your business policy, and here there is a measure to how to handle. Similarly, here also we have same set of things. So, this is true when we talk of the special data set also, we can have special item sets or a particular location and so and type of things, right. I can have different type of goals into the or to be analyzed on measured matrices. And this what we say about fact constellation schema. So, it is again if you see this is the star like, but here I have a thing called in the location that what we not only item set is in time is that time key, this is the shipping fact, like how the data are being shipped. So, it is the time key is connected to this time table, right. So, item is to these things, location is the location table from and to locations, and it has a dollar cost unit etc. for shipping, right. There can be a shipper, right. So, you see there are different. So, this is one sort of a fact table, this is another fact table, right, which are connected with different type of these dimension tables or the dimension tables which are connected to these two type of fact tables. There can be multiple fact tables into the things. So, this sort of things is more of a what we look at as a fact constellation. Again come back. So, one is that popular star schema, it is just star like of things. Then we have a snowflake schema. So, it is star, then again expanding, and then we have a facts constellation schema where we have multiple fact tables which are referring to different type of dimension tables and have the things like that. So, there can be different way of handling. So, it is based on the need we can have this particular conceptual model of the data warehouse. So, that need to be planned a priori, because based on this the data warehouse will be built up, right. So, there is another thing called concept hierarchy, like here if you say the concept hierarchy, office to city, city to country, country to region to all. I say departmental store, or that stores are there, it is for a particular city, say Kharagpur or Kolkata, so many stores of particular brand. And then if I want to aggregate, so if I want to find out the sales at the store level or the particular office level or the outlet level, then at the particular city level, country level, region level, all means at the top of the things, right. So, like I can have here example a particular country, over that it is a particular region, then country, then particular city or state, and then particular stores and go on. So, this is the way I can conceptually I want to do this hierarchy. How it is built up based on my analysis need or based on my requirement of my decision support system, right. It could have been other way also. I may not look at the city, directly go to the country and type of things, right. So, that can be, or below city I can have a city regions, right. So, particular region, southern part, 4-5 blocks of the cities and type of things. So, that all depends that how you want to look at those type of things, right. So, that the concept hierarchy, based on that the warehouse is built up, because your query are over that targeted things. So, you see this is a multi-dimensional table. So, dimension, product, region, another this it is there, it is little bit came down. So, it will be the temporal scale of the month out here. So, one is the temporal particular product in a particular region, right. So, cuboid. So, any cube in this cuboid represent that for that particular things, what are the things. If I want to know all the regions, then I basically aggregate this, right, on these two things will be there. And if I have all together, then I can have for all type of things. Now, you see I can take a piece of the thing, either slice, dice or a chunk of the things to find out the different type of, suppose this is gives the sales, right. So, product, month, region, and we can have a different hierarchy, like product can have a category and for a particular industry, office, city, country, region, time may have a different dimensions, right. I can have it day will be here, day, and then this will be, this week should be here, month should be here, and year should be here. In other sense, I have a year, then quarter, then month, week, day, right. So, number of days will constitute this week, right, 7 days, 30 days or 31 days or 28 days, 29 days with the month, right. So, 3 month is a quarter, or I can define a quarter as 12 weeks as a quarter. Again 4 quarter is in a year. So, there are two type of hierarchy, one path may be this way, one path may be this way, right, but these are all others way, this is only one sort of hierarchy. So, there can be different type of concept hierarchy over I want to calculate, right, routine calculation, unless there is some typical situation I want to calculate something else, these are the different hierarchies. So, what we are trying to see here, the basics of warehousing, some of you already knowing, for them it is a repetition, but basic of hierarchy things are there. Though we are looking on some other aspect like sales etc., but it fits into different of the spatial data sets per se, right. So, for the spatial database. So, we will continue our discussion on the spatial warehouse and spatial data mining in our next lecture also. So, that we have a overview of that how things work. So, that when we talk about now this data mining or spatial data mining aspects, when the analysis part, we are able to know that what this is, those are built on these basic fundamental things only, right. Okay. So, we will continue our lecture in our continue our discussion in the next lecture. Thank you.